A chatbot can only talk. An agent can act on your behalf. It can search the web, run code, query a database, book a thing, and chain multiple of these steps together until a job or a goal is actually achieved. So the word agent sounds like science fiction, but underneath it is something you could write yourself. It's basically a model, a set of tools which is available to that particular model, and then a loop. So over the next few minutes, what we will do is we will build that loop from scratch, see how the model decides what to do, and look honestly at where agents actually fall apart. So we'll start with a clean definition. So let's say a plain language model is a function. Text goes in, text comes out, and that is the end of it. Basically, it cannot check today's price, count a number of letters in a word, or send an email, because basically it doesn't have any hands. An agent, what it does is it wraps that model in a system that can take actions in the world and feed the results back in. So the model becomes the decision maker, choosing what to do next, while your code becomes the hand that actually does it. So the key shift is that one prompt and one answer becomes many small steps where each step's result shapes the next. That feedback is what separates an agent from a chatbot. So when I mentioned the hands are tools and the mechanism is what you call a function calling. So you describe each function the model is allowed to use as a schema, and then you expose that into a particular model. So inside this particular schema, you will have its name, what it does, and the arguments it takes. You send those descriptions along with the user's request to the model. So as I said before, the model cannot run code. So instead, it returns structured JSON saying which function to call and with what arguments. For example, get weather with city set to Tokyo. Your code reads that JSON, runs the real function, and gets the result. The model never touches your system directly. It only ever requests an action in a format you can validate. This one idea, a model that outputs a function call instead of prose, is the foundation everything else is built on. So now you connect this into a cycle. This is the core pattern, often called reason and act. In short, we call it ReAct pattern. So the model looks at the goal and the history so far and reasons about what to do next. It picks an action, a tool call, your code runs it, and it captures the result and the observation. Then you append that observation to the conversation history and hand the whole thing back to the model. So the model will reason again, now better informed with the new information which you gave, and chooses the appropriate next action. Reason, act, observe, repeat. The loop continues until the model decides it has enough to answer, at which point it returns a final response instead of a tool call. An agent is quite literally this while loop wrapped around a model. So for anything beyond a single step, like chaining multiple tool calls, what it does is a good agent plans before it actually acts. So let's say faced with a huge request like research 3 competitors and write a summary, it first breaks these goals into smaller tasks, then works through them. Like there are two options. Some agents actually do this in planning everything upfront, producing an ordered list of steps. Others plan one step at a time, deciding the next move only after seeing the last result, which adapts better when things go sideways. In production systems, strong systems actually use a mixture of both, a rough plan for direction, re-examined as new information arrives. The lesson from practice is that asking the model to think before choosing a tool to lay out its reasoning measurably improves which tool it picks. Planning is just decomposition plus the freedom to change the course. An agent that forgets everything between steps cannot actually get far. But unfortunately, our context window is finite and it fills up like very fast. So agents have two kinds of memory. One is short-term memory, the other one is long-term memory. So short-term memory is the running conversation, the recent steps it has run, and the observation it is being held directly in the context itself. When that grows too long, you summarize older parts to save space. So long-term memory lives outside the model, often in a vector database, the same retrieval idea we did it in RAG. So the agent writes facts and past results there and pulls back only the relevant pieces when a new task actually needs them. So the working context always stays small and sharp, while the agent can still draw on everything it has seen across a long session. Memory is what makes an agent feel persistent instead of like goldfish kind of memory. One agent juggling 10 tools and a giant prompt will always get confused, the same way a person behaves when he's overloaded. So a common pattern in this agent world is that you will have an orchestrator agents and it will have multiple specialized agents under it. So what the orchestrator agent does is that it will own the goal and it will delegate to these specialized agents. A researcher agent in this particular example only searches and reads. A coder agent only writes and runs code. A writer agent only drafts the final output. So each of these has a narrow job, a small toolset, and a focus prompt, which makes it more reliable than one generalist trying to do every single thing. So the orchestrator hands out subtasks, collects the results, and assembles the final answer. It is the same idea as a team: smaller responsibilities, clearer boundaries, fewer ways to go wrong. So here is the honest part. Agents are powerful, but they are fragile as well. Errors actually compound. If each step is 95% reliable, 10 steps in a row land near 60%, because small mistakes multiply across the chain. Agents do get stuck in loops, calling the same tool over and over, convinced that the next try will differ. They go off track, pursuing a misread of the goal with 100% confidence. And every step is another moral call. So cost and latency also add up like pretty quickly. So none of this means agents do not work. It means the difference between a demo and a product is almost entirely in handling these failures, not in the happy path everyone actually shows off. So like once you have this agents breaking thing composed of, and then you figure out okay how we can do it, one other thing we can actually do to avoid that is guardrails. So what you do is you wrap the loop in controls, cap the number of steps, so a stuck agent will always stop instead of running forever and burning money. So let's say if you give 20 steps, if it hits 20th step, it will stop and then goes to the next one. So another thing is what you can do is validate every tool call before running it, checking for the arguments and refusing anything dangerous, like deleting your code base or anything, because the models JSON is a request, not a command which you blindly obey. So as I said, keep risky actions like deleting data or spending money always behind a human approval step. Given tools permission boundaries, so give tools permission boundaries so a researcher agent simply cannot reach the production database, and log every step, the reasoning, the call, the result. So when something goes wrong, you can see exactly where. So when you put it all together, a minimal agent is surprisingly small. You need a model that supports function calling, a handful of well-described tools, each one a normal function inside your code itself, which you control. A loop that sends the goal and history, reads the model's chosen tool call, runs it, appends the result, and repeats it. So a stopping condition, both a final answer and a step limit, which also help us in creating a better agent. And then the memory, as we talked about in the previous sections, that conversation context plus a store for anything that must outlive it. That's in long-term memory. That is the whole machine. So frameworks can actually manage the plumbing for you, but none of this is actually mysterious. An agent is a model making decisions, your code taking actions, and a loop carrying results between. So this is an agent end to end, a model that can request tool calls instead of just talking. So tools are actually described as schemas run by your code with results fed back in. A loop that reasons, acts, and observes until the job is actually done. So planning to break big goals into steps and memory to carry knowledge across them. Split the work across specialized agents when one gets overloaded, and above all, guardrails, because errors compound and a free running agent is always a liability. Strip away the hype, and an agent is a while loop around a model, some tools, and memory. So now you can see every single part and build one yourself. I hope I have helped you understand how an agent works. If you have any questions, let me know in the comments.